Today we're going to build a next generation search engine in Python. To be precise, it's going to be an AI agent with access to multiple different data sources which it can use to give us an answer. For example, it will have access to Google search, Bing search, ChatGPT, Perplexity, X or Twitter, Reddit, and depending on what we're asking, it's going to determine which of these data sources to use, and then it's going to take information from there, aggregate it, summarize it, and give us an answer, including sources and relevant links. That is going to be a very interesting project, so let us get right into it. Alright, so we're going to build a next generation search engine in Python today. And as I already mentioned, this means we're going to build an AI agent with access to multiple different data sources, or we could also say APIs, that is going to get information from these data sources and aggregate them and give us a response based on our query. So to give you a brief idea of the structure of this project, of the stack that we're going to use LangGraph and Python, which is a library for creating agents, AI agents, and we're going to define different functions which are going to represent the various data sources that we have, and we're going to annotate these functions as tools. So we're going to say, for example, one function is going to be called Google search, takes a parameter query, and returns some text, some links, some JSON object with context that is relevant for our language model that is going to be the heart of the agent. And this is going to be annotated with an @tool decorator, where we're going to provide the information that this is one tool that our agent can use. We're going to do that for Google, we're going to do that for Bing, we're going to do that for ChatGPT, Perplexity, Reddit, and X or Twitter. And we also trust our model to decide which of these tools are useful for the task at hand. For example, my query could be something like, give me some summary of the current sentiment about a certain topic. And then, of course, what would make sense is to go to Reddit, to go to X to get the information, because that's where people post, that's where people have discussions. Whereas if I ask for something technical, for something that has to be researched, for example, more information about a specific individual or a specific period in history or a framework or something like that, it makes more sense to go into Google, to research, to use Perplexity maybe. So depending on the task, depending on the query, our next gen search engine will use the proper tools and give us the context that we need, and also an answer that summarizes everything it found. So that's basically the idea. Enough of the talking now, let us get started. And before we can start with the actual coding, we need to set up a couple of things first. Some API keys that we're going to use here, some libraries that we need to install. And one very central thing here is we need to have some interface to get these requests, to get these Google responses, the Google search, the Bing search, the Perplexity response and all that, to get this in a reliable way without getting blocked, without having problems with latency and so on. And for this, we're going to use the sponsor of this video today, which is Bright Data. So this is not just a mention, this is part of the project, so I would not skip that. This is going to be our interface to the world of SERP APIs and also to the world of scraping and to the world of working with ChatGPT and Perplexity. So this is how we get our data into our agent. So our agent is going to send requests, and it's going to do that via Bright Data. So we're going to ask Bright Data to get us some information from Google, from Bing, from ChatGPT, from Reddit, from X, whatever, and it's going to handle everything for us. The only thing we need to do is we need to provide the query and parameters like the format that we're interested in. Everything else will be done through Bright Data, because in this way, they are, as the title already says here, the all-in-one platform for proxies and web scraping. They make a lot of things easier. They provide multiple different services, web scrapers, web data sets, SERP APIs. They allow us to access all these things without worrying about IPs, without worrying about proxies, locations and all that. They handle all of this for us. And if you have something that is going to be used by many people, or something that is going to be used all the time, maybe just by a single person, maybe in an automated way, you need to have some interface that allows you to access all these sources without being blocked, without experiencing any problems. And that is what Bright Data is for. So we're going to use them. They're also, as I mentioned, the sponsor of this video today, so you'll find a link to them in the description down below. That is one thing. The other thing, of course, is we're going to need OpenAI itself, because our agent will use a language model as the base intelligence, so as the coordinator to choose the tools that we're going to use, to choose the queries that it's going to pass to these tools, and to also summarize everything and give us an answer. For that, we're going to need an OpenAI API key. And for this, first and foremost, I'm going to navigate here to my tutorial directory, and I'm going to create a file called .env. This is the environment's variable file. This is the central file where we're going to store all the important keys, all the important identifiers. And we're going to start here by saying bright data underscore API underscore key. And we're going to leave it empty for now. Then we're also going to need the bright data underscore SERP underscore zone. What is that? That's basically for the search engine for Bing and Google. We're going to need a SERP API, which is I'm going to show you how to set it up in a second here, but we're going to need a SERP API, and that is going to have a zone, which is, as you can see here, the zone column. Again, we're going to talk about this in a second. This is something that we need to provide here. In addition to that, we also need to provide the bright data ID for ChatGPT. So GPT dataset ID. Same thing for Perplexity. This is just the identifier for the scraper that allows us to interact with GPT and Perplexity, like this. And then, of course, we're also going to need the OpenAI API key. So OpenAI underscore API underscore key. Now, two of these values are something that you should not share with anyone, the API key for Bright Data and the OpenAI API key. So for this here, what I'm going to do is I'm going to just leave a placeholder here. I'm going to say your, maybe let me do that in quotation marks. It's going to be your Bright Data API key. So here you have to put your own API key, and for OpenAI, the exact same thing, your OpenAI API key, like this. And the rest is not something that has to be kept secret. This is just the name of your zone, the name of your SERP zone. This is just a public ID for the GPT dataset. This is just a public ID for the Perplexity dataset. So these are not secret values. We can explore them together here. Now, how do you get a Bright Data API key? First of all, of course, you create an account, you log in, and then what you do is you go to your account and you click on account settings. Once you're in the account settings, you just go down here to API keys and you click here on the three dots and say refresh key, revoke key, or maybe if you don't have a key, there's going to be a button here for creating the key. But you just go to account settings, API keys, and here you will find a way to create a key. You want to copy that key and you want to paste it here as your Bright Data API key. For OpenAI, same thing. You log in, you go to your account or to your settings, you go to API keys, and here you just create a new secret key, or you use one that you already have. Again, copy it and paste it here for OpenAI key. Now, these three are very easy to obtain. In order to get your SERP zone, you just go to proxies and scraping, you go to add, you go to SERP API down here, so instant scraping for search engines, Google, Bing, etc. You click on this, you name it in a certain way, for example, SERP API 1, SERP API 2, or something completely different. Then you can optionally also adjust the settings here, and once you're done, you click on this add button to create this new zone. You just click yes, and now you have a new zone. You're not going to need any of the details that you find in the zone itself, just focus on the zone name. In my case, I'm going to use the SERP API 1, which I already had before. You can see I had some traffic here already. I'm going to just use this one. Just use the one you created, the zone name, and the API key is going to handle the authentication. For interacting with ChatGPT and Perplexity, we're going to go to the web scrapers, and then we're going to click here on new, browse scrapers marketplace, and we're going to type ChatGPT. This is going to take us to chatgpt.com. We can click on that. We can click here scraper API, next. And the only thing that we're interested in now is here API request builder. And down here, you can get the dataset ID. So just copy this thing here and you have a dataset ID, take it and just put it here for Bright Data GPT dataset ID. Go to web scrapers again, go to new again, browse again, and now type Perplexity. This is going to allow you to use Perplexity AI, search by prompt, scraper API, next, request builder, and then just again, the dataset ID. By the way, maybe there's an easier way to get it. This is just how I always found it. It's dataset ID equals, and then you have this dataset ID here. This is how I always get it. But of course, there might also be a more convenient way to do that. So just copy that and paste it here. And here we set SERP underscore zone 1. So that's basically all you need from Bright Data. This allows you to use everything in your code now, so you can actually close the browser. You don't need it anymore. So just make sure you have the proper API key. Make sure you also have the OpenAI API key. In my case here, I'm going to edit this now off screen, and then we're going to start with the coding. And of course, before I do that, it's not SERP Zone 1, it was SERP API 1. All right, so now that we have all of this, we're going to start with the actual setup of our environment. For this, we just need to install a couple of packages. You can do that either with your ordinary Python version that is on your system. So either by saying pip or pip3 install, and then the packages. For example, we're going to use requests. We're going to use other packages, just pip or pip3 install, and then the packages separated by white spaces. What you can also do, this is a little bit more professional, is to create a virtual environment for the project to not have it interfere with your other Python installation. So you can do Python or python3-m venv.venv to create a virtual environment. Then you can activate that environment and do the same thing, like pip3 install. Or you can also use UV, which is what I'm going to use. It doesn't really matter. You can use any of these and have the same effect. So don't feel like you have to use UV just because I'm using it in this tutorial. It's just a more modern way to do this. So in my case here, what I do is I say UV init to create a UV project. And then I say, instead of pip or pip3 install, I just say UV add and then the same package names. Nothing else changes. It's just UV add instead of pip or pip3 install. So we're going to use the following packages today: requests, obviously for sending requests to Bright Data. Then .env, or actually it's called python-.env. This is a package that allows us to load the .env file into our environment so that we have all these keys that we just set, all the identifiers, and we can load them in the environment so we can use them in the code. Then I'm also going to use LangChain. I'm going to use a LangChain OpenAI. I think it's underscore or dash, probably dash, LangChain OpenAI, and then also LangGraph. So this adds all the packages. You can do the same thing with pip install. And now I'm also going to activate the virtual environment that we have here by saying source venv bin activate, just so I have some auto completion here. And then I'm going to go into the main.py file, and we're going to get rid of the code that's already in here. So we're going to start this from scratch. Now, what we're going to do in this video is we're going to build this search engine. We're going to build this agent as a CLI application, and then later I'm going to show you also what it looks like in a Flask application. You're going to find the entire code for this video in the description down below on my GitHub, so you can just copy paste it. You can have it on your second screen, code it, or try to code it from scratch while watching or while trying to understand what is happening while you're reading it. And also I'm going to provide the code for the web application, but we're not going to code it today. I don't want to spend too much time here doing HTML, CSS, Flask, and so on. I have many videos where we do that already. Today I want to focus on the search engine, on the agent, and we're going to build it as a CLI application to keep it simple. And then I'm going to show you what it looks like integrated as a Flask application, and you're also going to get the code on GitHub. Now let us get started with the imports. I'm going to start by saying import OS. This is going to be used to get the environment variables into the code. So python.env is for getting them from the .env file to the environment. And with OS, we can get it from the environment into our code. Then we're going to also use time so that we can have some delay for retrying certain things that we're going to need later on. We're going to, of course, import requests to be able to send requests. We're going to import from .env the function load.env. And then for the agent stuff, we're going to say from langchain.tools, we want to import the tool annotation from langchain underscore OpenAI. We're going to import the chat OpenAI class. Then from LangGraph.prebuild, we're going to import the create React agent. React here doesn't mean React as in the framework, so it has nothing to do with JavaScript. It's for agents. And then we also have here from LangGraph.graph, we want to import the state graph and this and constant, which is basically going to be the terminating state in our graph. In a nutshell, for those of you who are not familiar with LangGraph, it's basically operating, as the name already says, on a graph. So it's like an automaton, you could say. You have these states, you have these individual nodes, and you have connections between those nodes. and your agent can transition between the nodes. So it can say, okay, this is my tool use node, this is my aggregation node, this is my summary node, whatever. In our case, we're going to have just a single agent node. But if you have a more complex agent, you can have different nodes and connections. And in the end, you want to get to a terminating node or state, which is the end state or end node, we could say here. And now we're going to load the stuff from our .env file. So I'm going to say here load .env, and now I'm going to turn all of this into Python constants. So I'm going to say here bright data underscore API underscore key is equal to os get env, and then the same thing, bright data API key. We're going to do the same thing now with the bright data serp zone. Also just replace it here. Also here for the GPT dataset ID, and also the same thing for perplexity. So perplexity dataset ID, and here the same thing. Now we don't need to import, or we don't need to store our OpenAI API key because it's going to be recognized already by chat OpenAI. It's looking in the environment for an OpenAI API key, so we don't need to do that manually. But we do need to construct some headers that we're going to use for the requests that contain the Bright Data API key for authentication. So we're going to say here headers is equal to a dictionary, and the most important field here is the authorization field, which is going to point to Bera, so a Bera token, and the Bera token is going to be the Bright Data API key, like this. And then also we want to specify that our content that we send is in JSON format, and that we also only accept JSON format. So I'm going to say here content dash type is going to be application slash JSON, comma, and then the same thing here with accept. So these are just going to be the headers that we send with every single request. And now we get to the interesting part, which is defining our tools. So the tools that the agent can use if it decides that these are reasonable tools to use, and it can also decide how to use them. For example, if I define a function here, Google search, that takes a query as the parameter, then of course our agent can decide, do I want to use Google search at all? And if I want to use Google search, what kind of query do I want to pass? It doesn't have to just take our query and pass it to the function. It can reason about it and think that, for example, a summary of the query or a truncation of the query, a small part of the query, is enough for Google, and it can pass here whatever it decides is best. Of course, we need to annotate that also with the tool decorator, but we're going to do that later on. First of all, in this function, I want to print that this tool is being used. So I'm going to print here, Google tool is being used, ... The reason for that is that if we don't do that, we don't see what the agent uses. We can only see the final result, the final response with the sources, but it doesn't tell us that it used Perplexity, Google, and Bing, for example. We can only guess, and by printing this, we can see if it uses the proper data sources and also if it uses multiple data sources. Then I'm also going to define the payload. The payload is what we pass in the request to Bright Data. The first thing here, the most important thing, is the zone. The zone is what we defined already here as Bright Data serp zone. So in our case, this is serp underscore API 1, whatever you called this. This is what you pass here. We get it from the environment. Then also we need the URL. The URL is not the URL of Bright Data, so this is not where we send the request to. This is a field, this is a key value pair in the payload, and here we pass now Google. So we say https://google.com/search ? Q is equal to, and then we're going to use a formatted string here. So I'm going to say F in front of the string, and in here now we're going to pass the query. However, the query needs to be formatted properly, so we need to make sure that this is in URL encoding, and we can do that by using requests.utils.quote, and we can just pass the query in here, so we don't have a problem. Otherwise, we're going to get an error. And then finally, to make sure we get a JSON object as a result, I'm going to say brd_JSON equals 1. So that is the URL field. In addition to that, we're going to say format is raw. And finally, we're going to say the country. If you want to choose a specific country here, that you want to be connecting from. So you can specify whatever country you want here, even if it's not your country. For example, I'm in Austria, I'm going to specify US, which means that the request is going to be sent from an American IP address to Google. This can be reasonable if you're interested in what you get when looking from different countries. So that is the payload for Bright Data. Now we're going to send this. We're going to say data is equal to requests.post. We're going to make a post request to the following endpoint, https://api.brightdata.com/request async equals true. And then all we have to do is we have to say headers is equal to headers and JSON is equal to payload. And we're interested in the JSON object that this returns. And this is now going to return individual entries with title and link and description, or we could also say with a snippet. And we want to get this and we want to format this in a reasonable way. So I'm going to say here results is equal to an empty list. And then I'm going to say for item in data.get, and the key here is organic. For each item here, I want to say results.append, and then I want to use a formatted string. Let me actually use double quotations here. I'm going to say title, colon, and then the title is going to be item. And then we're going to use single quotations in here, title. Then I'm going to use a line break. Then I'm going to say link is equal to, and then item link \n, and then snippet is going to be equal to item. And here now we're going to use get description if it's available, otherwise empty string. So that is how we craft our results list. And finally, we just say return double line break dot join all these individual items. So results like this. And to not have too much context here, we're going to limit it to 10,000 characters. This is now arbitrary, of course, I know, but we're going to do it like this. So the cool thing is, if this works, and chances are I have some typos somewhere, maybe I have to fix that later on, but once this works, you can just copy that and do the exact same thing for Bing. So I can just paste this here. I can say Bing search is the exact same thing. Bing tool is being used. The only thing I have to change here is I have to say Bing. So bing.com, and that is essentially it. Nothing else changes. The rest is the same because it's a unified interface. Bing, Google, you just have Bright Data here as your endpoint. You provide what you're interested in, and you get the same structure as a JSON object. Now for Reddit and X, we're going to do the same thing. So I'm going to just copy here the Google search. I'm going to go down here. I'm going to paste the Google search, and I'm going to say now Reddit search. And I'm going to say Reddit tool is being used here. And the only thing we're going to do here, we're not even going to change the URL. We're just going to change the search query, because what I'm going to do here is I'm going to say now site : Reddit space plus query. This is going to limit the results that Google gets to be from Reddit. So it's going to actually not Reddit, sorry, reddit.com. And the same thing for X. So I'm just going to copy this. I'm just going to paste this, X search, X tool is being used, site x.com. That is the difference here. Now, very important for all of these is we need to annotate them with the tool decorator. So we need to say here add tool, and then description is equal to, and here you provide something that is important for the model to know. For example, you might have a use case where you want to use Google every single time a certain keyword appears. In this case, provide it here as context. In my case here, I'm just going to say search using Google so that the agent knows what this tool is for. So let me copy that. I'm going to do the same thing here for Bing, and the same thing also for Reddit, and then the same thing also for X. There you go. So these are already 4 tools. Now we need the GPT tool and the Perplexity tool. How do we do that? We define a function GPT_prompt. Once you have one of the two, the other one is quite simple. It's basically the same thing. We also provide a query here. We also provide a tool decorator here with a description. We can say for ChatGPT, use ChatGPT to get an answer to a question. that makes more sense than saying search with ChatGPT because it's not necessarily about searching. So that is more for explaining stuff, maybe if it needs that. And here I'm also gonna use a print message. So I'm gonna use print GPT tool is being used, but the rest is now not the same as before. Now we still have a payload, but the payload looks differently. Now it's a list, still a JSON object, but it's a list, and the list contains dictionaries, and a dictionary, in this case just a single one, is going to be pointing to URL. The URL is going to be ChatGPT, so we're going to say here https://chatgpt.com, and the query is going to be the prompt. So prompt is going to be pointing to query. That is a payload, and we also post this to a different URL, and it also works in a different way because we're going to get not the answer back, we're going to get an ID, and this ID is going to point to a snapshot. We need to query if the snapshot is ready, and then we need to get the information from the snapshot when it's ready. So the URL here is the following: https://api-brightdata.com, same as before, but now /datasets/v3/trigger $dataset_ID. Now we need to make this an f string is equal to, and we provide here the bright data GPT dataset ID. Then also and format is equal to JSON, and then also custom_output_fields is equal to, and we're interested in the answer text markdown. So now we can make a post. Response is equal to requests.post to the URL with the same headers and with the payload here. And as I said, this is going to return now a snapshot ID. So we need to capture that. The snapshot_ID is going to be equal to response.json and then snapshot ID, like this. And now we need to ping another endpoint to see what the status of this particular snapshot ID is, whether it's ready or not. And if it's ready, we need to ping yet another endpoint to actually get the response. So we're going to say here, while requests.get, and the URL now is still https api-brightdata.com/datasets/v3, but this time it's /progress, and then / we need to make this an f string /, and this is now going to be our snapshot ID. So we're asking what's the status of the snapshot ID. I'm going to also use the same headers here as before. And from this now we want to get the JSON object and we want to get the field status. While this particular field is not equal to the exact string called ready, so ready is what we're looking for. While this is not the case, what we're going to do is we're going to do time sleep 5. And we're going to do the same thing again. Since this is now in the head of the while loop, this is going to be run every time. And we're going to ping and try to get the new status all the time. If it's ready, we're going to break out of the loop. And otherwise, we're going to wait 5 seconds and try again. So once we're out of the loop, we know that our snapshot is ready. And we're going to get the data by saying, again, another endpoint here, requests.get. https://api-brightdata.com/datasets/v3, and this time /snapshot/ and then snapshot ID. Then format equals JSON. Headers also have to be headers again. Make sure we have the authentication and everything. And then we're going to get the JSON object, and we're going to say, give me the first element here. So give me index 0. That is how we get the data. And finally, in order to get the actual answer now from GPT, we need to say return data and the field that we were interested in extracting, answer text markdown. So if I didn't make any mistakes, this is how you do that. And the coolest thing is now I can take that and I can easily adjust that to work for Perplexity. So I can say here, use Perplexity to do some research for a question. For example, do I have a dot here? I don't need that. So just use ChatGPT, use perplexity. There you go. Then we should say perplexity tool is being used. I'm going to call this perplexity prompt. And then, of course, we need to change this here to www.perplexity.ai. And besides that, of course, also change the dataset ID. So make sure you have the perplexity dataset ID here like this. And one more thing that we can do with perplexities, we can add a pipe symbol here and say we're not just interested in the answer text markdown, we're also interested in the sources. So we want to take the sources and we also want to return them as context or as an answer here. And the rest stays the same. Then we can just say in the end here, in addition to the answer text, I want to do 2 line breaks, and I want to say also add here, of course, we need single quotation here again. Also do here data get sources if you have any, otherwise just an empty list, and that's that. And now we're almost done. These are the tools. This is where the magic happens, and the rest is just a basic LangGraph agent. So we're going to say here the LLM is going to be equal to chat OpenAI. The model name is going to be GPT-40, quite simple. Then the temperature is going to be equal to 0. Then I'm also going to say here agent is equal to create React agent. This allows us to create the agent. The model that we use in the agent is going to be our LLM here. This, by the way, as I said, automatically takes the OpenAI API key, provided that you call it exactly OpenAI_API_key. It will not recognize it if you have it like this, Open_AI. If you have it like this or anything like that, it has to be OpenAI_API_key. Then here the model, the tools are also relevant. We're going to pass here the list of Google search, Bing search, GPT prompt, perplexity prompt, Reddit search, and X search. These are the tools. Debug is equal to false. And then important here, I'm missing a comma. Important here, you also can provide a system prompt, and you should provide a system prompt that describes or that explains to the agent how it should use the different tools or how it should use tools in general. So you can say here prompt is equal to, and because I don't want to type this out again, I'm just going to copy the system prompt I used here in my prepared code. It's not necessarily the best prompt, it's just one that worked for me. And it looks like this. Use all tools at your disposal to answer user questions. Always use at least 2 tools, preferably more. When giving an answer, aggregate and summarize all information you get. Always provide a complete list of all sources which you used to find the information you provided. Make sure to add all links and sources here, not just a few superficial ones. That is the system prompt. Feel free to adjust that however you like. Feel free to also adjust the descriptions here. And once you have that, what you can do is, let me just delete this line here. What you can do is you can create an agent node function. So that is going to be a node in the graph that LangGraph uses. I'm going to call this agent_node. It's going to take a state like any other node here in LangGraph as a parameter. And we're going to say in this node, what we can do is we can invoke tool use. We can invoke something. We can invoke the agent based on the prompt. So we're going to say here agent.invoke, and we're going to pass a dictionary here with the key messages. Messages is going to point to a list in which we have in parentheses here. So in a tuple, human, and then state query. So the current state that we have here, we get the query from that, and this is what we pass here to invoke the agent. Then we say state answer. So we work with the state that we pass here in the individual nodes. That is going to be the result, messages, and then -1.content. This is how you do it in LangGraph. What you return here is just the state itself, because every node takes in a state, returns a state. That's the general principle here. And now we can just create the graph with this node, with the end node as well. And we can do that by saying graph is equal to state graph. We're going to initialize that state graph with an empty state, so just an empty dictionary. We're going to say graph.add note, and we're going to add our agent note with the string or identifier agent. Then we're going to say graph set entry point is going to be our agent node. And then we're going to say graph.add edge, and we want to be able to go from the agent node to the end node, which is the terminating state. Then we just say app is equal to graph.compile. And finally, we say if dunder name is equal to dunder main, then we just say query is equal to whatever the user puts in. You can say query like this. And then we are going to say print app.invoke. Invoke like this. I'm going to say query, and then from that, the answer. There you go. I'm sure I have made a typo or some mistake somewhere, but let's see if this works. We can just go ahead and say Python 3 main py. Of course, I have a problem. This is because we have an f string with single quotation, and I'm also using single quotation inside. That is for Reddit and for X, so we need to make sure we use double quotations here. That is something that should be fixed with Python 3.12, I think, but I think I'm using 3.11 here, which is why this doesn't work. At least I think so. And for X, we do the same here. So there you go. Let's see if that is the only problem. Okay, actually, this was a mistake. We don't pass here an empty dictionary. We pass dict as a class here. And then I can type a query. Let's do something like who is neural 9? Question mark. Now you can see that simultaneously Google, Bing, Perplexity, Reddit with 1D, I need to fix that, and X are being used. So everything except for ChatGPT itself, probably because it is ChatGPT what we're using here. And now these are going to return responses. And once everything is collected, it's going to give me a summarized answer with the sources. All right, so there you go. We have a quite comprehensive answer. We have here is an educational brand focusing on blah, blah, blah. Then you have key activities, YouTube tutorials, GitHub repositories, educational books, services, and so on. Okay. And then we get here the links that it used for getting the information. So we have here neural9.com, youtube.com/neural9. We have GitHub, Instagram, LinkedIn, Reddit, and X. So yeah. That is what it looks like in a command line. Let's see what it looks like if we turn this into a Flask application. Again, the code here is going to be provided to you by going to the link in the description down below. The second one is going to be to the GitHub code, so you can just copy paste it from there. I'm not going to build a Flask application here now because the focus is on building the search engine and the agent. So here I have a Flask agent project. It consists of a simple app.py file and a templates directory with a single index HTML file in it. Basically, when we take a look at the code, it's what we had before, the same bright data stuff, Google search, Bing search, and so on. In addition to that, we have Flask. So now we have also a web application, which we can see down below all these tools that we already had before. Below the agent creation, we also have now here Flask application and a single index endpoint, which is vibe coded. So it just takes the request, invokes the agent, gets the response, and then everything is formatted kind of beautifully here in the HTML. So we have some CSS, we have some JavaScript, some loading animation, and all I have to do now is I have to say, first of all, uv add Flask or pip3 install Flask. And once you have that, Python or Python 3 run, or not run, sorry, this is uv, Python or Python 3 app.py. And this is going to open it on localhost. Now here I have my next gen search engine. And here it already suggests something that I typed in. When will Python 3.14 be released? But since this is a search engine and not a chatbot, actually let's go and say Python 3.14 release date. This is how I would Google that. So let's search and let's wait for the answers. Meanwhile, we can see here in the command line, Google, Bing, and Perplexity are being used. So it decided to not use Reddit, not use X, and not use ChatGPT. There you go. So we get our response. Python 3.14 is scheduled for official release on October 7th, 2025. This release follows a development cycle and so on and so forth. And then we have here the sources. We have the PEP. We have the official Python sources where we can find that information. Let's try something else. Let's say current sentiment on Intel CPUs. I don't know. For this one, when we look into the command line, we can see Reddit and X are being used as well, because now it's about sentiment. Now it's about what users think, and it makes much more sense to also look into Reddit and X. Okay, there you go. We have a quite comprehensive response now. We have the current sentiment on Intel CPUs in 2023. This can, by the way, be fixed. We're using 4.0. The knowledge cutoff is in 2023. So if you want to provide information that currently it's 2025, 2026 at some point, then you can just pass some basic string to or some basic information to the system prompt with the current timestamp, with the current date, and tell it that this is the current date. But yeah, don't be too confused by that. We can see here some market share stuff, some weaknesses and strengths, and we can see here Reddit discussions. We can see, Seeking Alpha. We can see Tom's Hardware. So different links that were found probably mainly on Google, Bing, and Perplexity, and of course this one with the Reddit search. But yeah, it gives us an overall sentiment, mixed sentiment, considered reliable and dominant. AMD is often preferred by enthusiasts. Yeah, there you go. So this is how you build a next generation search engine in Python with Bright Data and LangGraph. So that's it for today's video. I hope you enjoyed it and hope you learned something. If so, let me know by hitting a like button and leaving a comment in the comment section down below. Of course, don't forget to check out Bright Data, the sponsor of this video. You're supporting the channel whenever you check out the sponsors. And also, of course, for this video, they were an essential part, a central component. So make sure to check them out at the link in the description down below. And of course, besides that, don't forget to subscribe and hit the notification bell to not miss a single future video for free. Other than that, thank you much for watching, see you in the next video, and bye.